Hello everyone, welcome back to class 6 series on my channel Mathify with Minakshi. In the previous chapter, we learned about chapter 1 patterns in mathematics, and now we are starting a new chapter, chapter 2 lines and angles. But before starting this chapter, we first need to learn some basic ideas of geometry. First and most basic concept is a point. Point is a basic unit of geometry. We know that geometry is a branch of mathematics that deals with shapes. And to draw any shape, first we have to start with a point. That's why is known as basic unit of geometry. And as you know that point has no length, no breadth and no height. That's why point has zero dimension. And point shows an exact location of something. We usually represent a point with the help of dot. It might be possible right now it's looking like a circle, but you have to put a sharp dot. Otherwise, it's a circle. Now let's move to second, that's ray. A ray starts from one point but keeps going endlessly in one direction. That means we can say it has a starting point but no ending point. And it has indefinite length as it can be extended indefinitely from one end. You know that here we have a starting point, but for the ending point we have arrow. That means it's going on. Now, one more thing you should know about ray, that it has one dimension. Let's move to third point. That's line. A line is different from a ray because it has neither a starting point and nor an ending point. That means it has indefinite length and it can be extended from both the ends. Yes, again it has one dimension. Finally, we have a line segment. A line segment has both a starting point as well as an ending point. So its length is fixed, or you can say definite. And that's why we say line segment has one dimension, and that is length. So we can always measure the length of line segment. One more thing, as the name says, line segment, that means segment means part. So line segment is a part of line. You can also say in this way. So remember, a point shows position while lines, ray and line segments shows length and direction. Most of the students get confused between dimension and direction. So you should know this thing, that dimension is a quantitative measure that describes the size or extent of an object or space. Like you know that line is 1D, line segment is 1D, ray is 1D, but when we talk about a plane, that's 2D, and similarly when we talk about objects, that's 3D. So that's mean dimension. But when we talk about direction, direction is qualitative, describing the orientation or path of movement, like north, east, south or west. Now let's move to next topic. Types of lines. So here I have written 5 types of lines for you. First, intersecting lines. When two lines meet at any angle, either acute, as you can see, these two angles are acute and they are equal because they are vertically opposite angles, or obtuse. These two angles are obtuse and even they are equal, but it can't be 0 or 180-degree, and wherever they meet, that point is known as point of intersection. Second is concurrent line. In intersecting lines, usually we talk about two lines, but when we have more than two lines that intersect at a point, then those lines are known as concurrent lines, and wherever they meet, that point is known as point of concurrence. Now let's move to third type, perpendicular lines. It's a special case of intersecting lines, as when two lines intersect at a point but now they meet at 90-degree. That means they are perpendicular to each other. Then we say that these lines are known as perpendicular lines. If one line we represent by L and second line we represent by M, then symbolically we can say that L is perpendicular to M like this. Let's move to fourth type of lines, parallel lines. When two lines are equidistant and never meet, that means the distance between these two lines is always same. If here it's 5 centimeter, then at any point you will see that distance is same, 5 centimeter. It can't be even 4.9 or 5.1. Now if first line is L and second line is M, symbolically we can represent these lines as L is parallel to M. This is a symbol for parallel lines. Let's move to last type of lines, coincident lines. Whenever two lines coincide each other, then we can say that these type of lines are coincident. Now let's move to figure it out. That's on page number 15 of your book Ganita Prakash. Question number 1. Rihan marked a point. That means 1 point. Question is how many lines can he draw that pass through the point? And here Sheetal marked 2 points. This time they said 2 points. On a piece of paper, how many different lines can she draw that pass through both of the points? So, first we'll draw for Rihan. We have a point. So, how many lines we can draw from this point? 1, 2, 3, 4, 5. Now you realize, ma'am, as many lines you want we can draw. Yes? Because from a single point we can always draw infinite lines, but they said lines, that's why you have to put arrows, otherwise it becomes line segment, and this is my point. Okay, so I will write that for you, that Rihan can draw infinite lines. You should know this thing, from a single point we can always draw infinite lines, from a single point. And if you want to mark that point, you can mark that point as O. Okay, now let's move to Sheetal. Sheetal have 2 points. So how many lines he can draw? That will pass through both the points. Only single line you can draw. Yes, the points are A and B. That means from 2 points you can always draw only one line. So I will write that Sheetal can draw only one line that passes through 2 points. Now let's move to question number 2. Name the line segments in the given figure. Which of the 5 mark points are on exactly one of the line segments, which are on 2 of the line segments? So first I will write those points that are on exactly one line segment. This will write first, and then next we have to write points that are on exactly 2 line segments. But first you should know that these line segments, what are the line segments? You can say LM, you can say LM or ML. I'm saying LM, then MP, then PQ, then QR. 1, 2, 3, 4. We have 4 line segments. One more thing I want to tell you, that while writing the name of line or line segment, like if you have this as line, then you can write this as either LM or ML. Similarly, if you have this line segment LM, you can write either LM or ML. But for ray, like if we have a ray like this, O and P, you have to always write OP. You can't write PO, because ray is always from point towards arrow. So you have to be careful. So I'm just removing this now. This is just for explanation that how you can write the name of line, ray and line segment. So for line and line segment you have a choice. Okay, so now I have 4 line segments. They are saying first is point that are exactly lie on one line segment. Just see, point L lies on only one line segment, that's LM, so you can write L. Then if you see point M, no, point M lies on both line segments LM and MP, and P lies on both line segment MP and PQ. Then Q lies on both line segment QP and QR. Then we'll write R, because R just lies on QR. Next is points that are on exactly two line segments. Now we have to see those points that lies on two line segment. So first you can write M because M lies on two line segments, ML and MP. Then you can write P because it lies on two line segments, PM and PQ. Then you can write Q because it lies on two line segments, QP and QR. So answer is M, P and Q. Let's move to question number 3. Name the race shown in figure 2.5. Is T the starting point of each of these rays? Just see carefully. First, you have to write name of race. How many rays are there? Let's write that first. Now, for this ray, you can write the name as TA. As I told you, you always start from point towards arrow whenever you have to write the name of ray. Now, this ray is TN, second is TN, if you will see from T to N. Now, from T to B, that's TB, and then last NB, you can say NB. Just I want to tell you one more thing. Most of the students thought that this NB is always a line segment. No, as you know that you can extend B towards right side. That's why I can write that NB is also a ray. Okay. Now question is T is the starting point for each of these rays. They are saying for all the rays. T is the starting point for TA, T is the starting point for TN, T is the starting point for TB. But T is not the starting point for NB. So you will write no, T is not the starting point for each of the rays. Because of NB we are writing this. Okay, let's move to question number 4. Draw a rough figure and write labels appropriately to illustrate each of the following. First, they are saying that you have to draw two lines OP and OQ such that they meet at O. So I will draw that OP and OQ such that they meet at O. But here they said OP and OQ. So you have to be very careful. That means O is the intersection point and just write P here and Q here. Yes, so name of the rays you can say OP and OQ. Clear to everyone? Let's move to B part. XY and PQ intersect at point M. This time this XY is ray. So let's draw that XY. XY. And next line is PQ. PQ. And they intersect at M. So this point is M. It's easy. Line L contains point E and F but not point D. I want to tell you one more thing here. When we have to write the name of line, what we can do? Either we can mark any 2 points on that line anywhere like here P, O or like this P, O, or you can simply use one alphabet and you can write that here like L. So there are two ways to mark any line. I will rub that now. So here they said that L is a line, so that means they're talking about this way where we'll write L at side. Okay, so we have a line L. Let me draw that for you. We have a line L and it's written points E and F. That line contains point E and F but not D. That means D is not on line. You can draw anywhere except on line. Now D part. Here it's written point P lies on AB. Now here it's not mentioned anything. That means you're considering this as line segment. So first you will draw AB as line segment and then you will draw point P on that. Yes. Now let's move to question number 5. In figure 2.6, that means this figure, name 5 points. So you have to write any 5 points. So you can write D, E, O, C, B. So let's write these 5 points. D, E, O, C, B. Second, a line. You have to write a line. That means single line you have to write. So you can write anything. So I'm writing DB. You can write BD, you can write ED, you can write EO, you can write OB, you can write BO. all are correct except OC is not correct because here we don't have any arrow. But from D, E, O, B, if you will write any combination, it's correct for line. For race, now again for race you can write anything. I will write OC. I will write OC first, second. But for A, you have to very careful. You have to start from point. Here you can't write CO because O is a point here. We can't move further towards left side. But when it's a line, whenever you have a line and someone say you have to write race, you can start from anywhere because we have arrows on both the sides. So you can write anything. You can write even DE or ED. You can write EO. You can write OB. You can write anything. It's always correct. Now, 5 line segments. Again, when it comes to line segments, you can write anything that you are seeing that we have 2 points. So DE, EO, OB, OC, and you can write DO or you can write DB, anything you can write. So I'm writing DE, EO, OB, OC, and DO. So please don't get confused. Whenever we have a line, that means using those points that are on line, you can write ray, line segment, or line. You can write anything. You have to be just careful for ray. In ray, it's always from point towards arrow. We can't write like CO because here there is no extension of this line. Let's move to next question, question number 6. Here is a ray OA, as you can see in this figure. It starts at O and passes through the point A. It also passes through the point B. Can you also name it as OB? Just see here carefully. They are saying, can you name this ray OA as OB? Yes, as just I told you that because we can extend it further, so it's correct. You can write yes. We can name OA as OB because the starting point should be same. Here the starting point is same, that's O, because they have O as initial point. They should have same initial point basically and move in same direction. For ray, we just need two things. First of all, they should start from same point and then they are extending in same direction. If yes, you can name it like OB, OA. And if you have further one more point C, so we can write also as OC. Move in same direction. Now B part, can we write OA as AO? Now, as I told you that whenever we have a ray like this OA, you can always write the name of ray as OA. We can't write this name as AO because we always start from initial point and then we have to move towards arrow. So they are saying, can we write OA as AO? No, we can't write OA as AO because they have different initial points. Different initial points and they move in different directions. Different directions. And that's it. We are done with our first figure it out. So now we'll continue this chapter in next video. If you found this video helpful, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Stay tuned for other videos of this chapter. Thank you everyone.